So let us start. So let me share the whiteboard. Okay. ओके लास्ट टाइम हमने किया था उसका वो सेल्फ इन्वर्सिव पॉलिनोमियल का। तो सेल्फ इन्वर्सिव पॉलिनोमियल होता है तो हमने डिफाइन किया था सेल्फ इन्वर्सिव पॉलिनोमियल को p of z is a self inversive polynomial if p of z can be written as some u times q of z where modulus of u is equal to 1 and q of z is जैसा कि हमने इससे पहले बहुत बार किया है it is p of 1 by z bar whole bar. अगर ऐसा है तो we call it self inversive polynomial. Now it's easy to see जो तुम खुद चेक कर सकते हो by taking that conjugate polynomial. It's easy to see that pz equal to an z raised power n plus a sub n minus 1 z raised power n minus 1 plus so on and so forth plus a1z plus a naught will be a self-inversive polynomial will be a self-inversive polynomial if aj is equal to a n minus j whole bar. You can easily check that, of course. J running from, of course, 0, 1. क्योंकि इसमें कोएफिशिएंट स्विच हो जाते हैं ना और कॉन्जुगेशन भी हो जाता है उनको. So you can check if this is true, then q of z must be self-inverse. Or p of z must be self-inverse. Example, so if I take p of z equal to z raised power n plus 1, both a simple example. Now what would be p of 1 by z bar? P of 1 by z bar would be 1 by z bar raised to power n plus 1. Right? And what would be p of 1 by z bar का whole bar? That would be इसको फिर से बार लगा दो. So that would be 1 by z raised to power n. Of course उसको बार लगाओ मतलब अब एक ही बात है. It's a real number, which implies that which you can write as सीधे लिख लीजिए. It means z raised power n into p of 1 by z whole bar is equal to z raised power n into 1 by z raised power n plus 1, which is nothing but z raised power n plus 1. That is, I've got q of z is the same as p of z. यही था ना? So it means therefore u की जगह 1 है ना? You can think of it as 1 जिसका modulus 1 है. So therefore p of z is self-inversive. Sorry मैंने गलत साइड से 1 लगा दिया. लेकिन क्या फर्क पड़ता है किसी भी साइड से 1 से मल्टीप्लाई कर लो. मेरे कहने का मतलब I write just 1 into, we can write p of z 1 into q of z, and of course modulus of 1 is equal to 1, so it is a self-inversive polynomial. Look at this. Okay, इसी तरह से एक और simple example हो सकती है. Say p of z is equal to z raised power n minus 1. Now again, what would be p of 1 by z bar? It will be 1 by z bar raised to power n minus 1. And of course, if you take the whole bar, what would be this? This would be 1 by z bar whole bar. So that would be, of course, 1 by z raised power n minus 1. And if you multiply by z raised power n, you will get this is equal to z raised to power n into 1 by z raised power n minus 1. That would be 1 minus z raised power n, which is minus 1, into z raised power n minus 1. That is q of z multiplied by minus 1. ये अपना qz है. अगर मैं दोनों साइड से मल्टीप्लाई में माइनस 1 करूं तो ये बन जाएगा z raised power n minus 1. That's p of z. So we have p of z is equal to minus 1 into q of z, where of course modulus of minus 1 is equal to 1. So it is a self-inversive polynomial. Similarly, you could have also taken, say, z plus 1 whole raised to power n, p of z. By the way, what would be now p of 1 by z bar? That would be 1 by z bar plus 1 whole raised to power n, right? And अगर इसको फिर से बार लगा दें तो p of 1 by z bar whole bar would be, of course, इसको कोई फर्क नहीं पड़ेगा, so it would be 1 by z plus 1 whole raised power n, which can be written as, we can take it like this, 1 by z into 1 plus z whole raised to power n, which would be 1 by z raised power n into z plus 1 raised to power n. So you have q of z जो कि बराबर है z raised power n into p of 1 by z bar whole bar would be equal to z plus 1 raised to power n, which is the same as p of z. So it is obviously a self-inversive polynomial. Okay, so ये examples हो गए, मतलब you can find out, you can actually construct any example using this condition. So you can construct an example of any type. Okay, now we have a theorem regarding these self-inversive polynomials. और theorem ये है, if pz is a polynomial, self-inversive polynomial. If pz is a self-inversive polynomial, we can actually improve the Bernstein inequality. Sort of, yes, of course, we can improve it. Okay. We can improve for a smaller class. जब मैं कहता हूँ inequality is sharp, यानी for all polynomials, Bernstein's inequality cannot be improved, but we can improve it for a smaller class of polynomials, that is self-inverse polynomials of degree n. Then maximum over mod z equal to 1, p dash z is less than equal to n by 2, maximum mod z equal to 1, p of z. And we can prove it. Actually, we will ultimately show that both sides are equal. But first we prove this side. By hypothesis, pz is a self-inversive polynomial. Therefore, p of z can be written as u times z raised power n into p of 1 by z bar whole bar over the polynomial. Let's call it 1, where modulus of u is equal to 1. If you differentiating both sides and treating u as a constant, so you can have p dash z is equal to, ये हम इससे पहले भी कर चुके हैं, u को बाहर रखते हैं, n times z raised power n minus 1. इसमें थोड़ा सा तुम्हें चेक करना पड़ेगा, but last time हमने एक थ्योरम में इसको डिफरेंशिएट किया था, so you can go back and इसको देख सकते हो. This is actually p dash of 1 by z bar whole bar. इसके लिए तुम्हें मतलब you have to first find this polynomial and differentiate, फिर इसका वो conjugate निकालना. Nevertheless, it implies that z into p dash z then should be equal to u into n times z raised power n p of 1 by z bar whole bar minus z raised power n minus 1 into p dash of 1 by z bar whole bar. Right? Now, which is nothing but u into, because this would be u into this. So अगर हम ये देखें p of z इसके बराबर है, so I can actually write it as n times p of z minus u times z raised power n minus 1 p dash of 1 by z bar का whole bar. Right? So which implies, इसको यहाँ लाएंगे u into z raised power n minus 1 p dash of 1 by z bar whole bar is equal to n times p of z minus p dash of z, of course z minus p dash of z. So which implies, of course, mod of u of z raised power n p dash of 1 by z bar, दोनों साइड से mod लेंगे, is equal to mod of n of p of z minus z p dash of z. अब almost हो गया. अब modulus of u is 1, so we can take it out and finish it. So it would imply, हमें क्या मिलेगा? It would imply that modulus of z raised power n minus 1 p dash of 1 by z bar whole bar is equal to n times p of z minus z times p dash of z. Okay. And for mod z equal to 1, if for mod z equal to 1, 1 by z bar is the same thing as z, because z into z bar is equal to mod z square is equal to 1. So if mod z is equal to 1, then उससे मिलेगा, therefore I have mod of z raised power n minus 1 into, इसकी जगह मैं लिख सकता हूँ p of z bar p dash, so p dash z bar is equal to n times p of z minus z times p dash of z for mod z equal to 1. That is, अब इसका भी मॉडुलस 1 है, that you would have, और बार का मॉडुलस और कॉम्प्लेक्स नंबर और उसके कॉन्जुगेट का मॉडुलस सेम होता है, so I have mod of p dash z is equal to n times p of z minus z times p dash of z. For mod z equal to 1, it implies that twice p dash z can be written as p dash z plus, of course, mod plus p dash z, but एक की जगह हम ये सब्स्टिट्यूट करें, p dash z plus n times p of z minus z times p dash of z for mod z equal to 1. And we know that this is less than equal to n times maximum of mod z equal to 1 of p of z. We have done it so many times now. अब is true for mod z equal to 1. अब कुछ नहीं है, 2 को इधर लाया. It implies that maximum, and took the maximum on the left hand side. P dash of z is less than equal to n by 2 into maximum mod z equal to 1 of p of z. Okay. So that finishes our theorem. But actually we can do something else. We can actually show the reverse inequality. So क्योंकि theorem इतना ही है, but we can actually show something, इसकी corollary. चलो मैं corollary इसी से हमें मिलेगा. प्रॉब्लम ये है ना कि इसको हमें यूज करना पड़ेगा. So remark, चलो remark ही लिखते हैं तुम्हारे नोट्स में. If pz is a self-inversive polynomial, of degree n, what does that mean? It implies then p of z can be written as u into z raised power n p of 1 by z bar whole bar, where modulus of u is equal to 1. And as before, so as जैसे हमने अभी ये theorem किया था, as before, हमें मिलेगा n times p of z minus z times p dash of z is the same as modulus of p dash z, of course, for mod z equal to 1. जैसे हमने वो किया था बिल्कुल वही हमें यहाँ फॉलो करना है. So we will get this, which would imply n times p of z in modulus can be written as n times p of z minus z times p dash of z plus z times p dash of z, and I added and subtracted the same thing. So this would be less than equal to n times p of z minus z times p dash z plus z into p dash z, which is equal to n times p of z minus z times p dash of z plus mod of p dash of z for mod z equal to 1, right? But using this for mod z equal to 1, this is equal to this. So this is actually equal to p dash z plus p dash z. So which implies that n times p of z is less than equal to twice p dash of z for mod z equal to 1, which implies that p dash of z, oh yes, कैसे लिखूं मैं? तो ऐसे लिखता हूँ, ये n by 2 को मैं पहले यहाँ पे लाता हूँ, right? So which is less than equal to maximum over mod z equal to 1 p dash of z for mod z equal to 1. लेफ्ट हैंड साइड पे भी नहीं है. अब हम लेफ्ट हैंड साइड से भी मैक्सिमम लेंगे तो व्हाट डू यू गेट? यू विल गेट n by 2 into maximum mod z equal to 1. What do I have? Okay, p of z in modulus is bigger than equal to, it's less than equal to, is less than equal to maximum mod z equal to 1 of p dash of z. तो हमने इससे बिल्कुल इससे उलट अभी प्रूव किया है ना, अभी हमने प्रूव किया था. Now as we proved in the above theorem, हमने क्या किया था? हमने इसका उल्टा किया था कि मैक्सिमम mod z equal to 1 p dash of z is less than equal to n by 2 times p of z. Hence, for a self-inversive polynomial, pz of degree n, what do I have? I can just replace it by equality. Maximum mod z equal to 1. Right. P dash z is equal to n by 2 into maximum over the unit circle of p of z. Okay. So ये हो गया. Now we can similarly define what we call self-reciprocal polynomial. So again, it's a definition. थोड़ा सा उससे different है self-inversive polynomial से. So we write it as a polynomial pz of degree n, a polynomial p of z of degree n is said to be self-reciprocal polynomial. Self-reciprocal polynomial if P of z is the same as z raised power n P of 1 by z bar. तो यहाँ एक चीज ध्यान रखना है, मतलब हमने फिर इसको बाहर नहीं चढ़ाया, राइट? तो वहां पे हमने u से मल्टीप्लाई भी किया था जब हमने डिफाइन किया था सेल्फ इन्वर्सिव पॉलिनोमियल. तो इट्स समवhat different than that. So in other words, we can say, which you can easily verify, P of z equal to a n z raised power n plus a sub n z raised power n minus 1 plus so on and so forth plus a1z plus a naught is self-reciprocal if, of course, aj is equal to a n minus j for all j running from 0, 1, 2 up to n. वहां पे बार था, मतलब you can easily check this is always true. Or of course इसकी भी examples है, you can easily construct any example by just putting aj equal to n minus j. Okay, just for example, you could take this polynomial z raised power n plus 1. This is of course self-reciprocal as well as self-inversive. So you can easily again check p of z ये है. What would be p of 1 by z bar? Oh, right. So that would be equal to, just a minute, is it? Okay, हाँ यहाँ coefficient तो match करते हैं. Let's see. So it would be p of 1 by z bar होगा 1 by z bar raised to power n plus 1. And if you multiply by z raised to power n, do we get it back? कुछ तो oh sorry, हाँ मैंने गलती की ना, तो ये कैसे हो सकता है? But you should have thought yourself, क्योंकि मैंने कहीं पे यहाँ बार तो लिया ही नहीं. So it has to be, यहाँ पर भी बार नहीं है. Oh, so it is 1 by z. अब सही है. अब वहां पे यहाँ भी बार था, फिर ऊपर भी. But in the case of self-reciprocal, there is no bar. तो तभी तो ये होगा, वरना यहाँ बार आना चाहिए था ना, क्योंकि conjugation होनी चाहिए कहीं पे अगर हमें p of z is equal to z raised power n 1 by z bar. Anyways, so then of course indeed p of 1 by z होगा 1 by z raised power n plus 1, and of course z raised power n into p of 1 by z is equal to z raised power n into 1 by z raised power n plus 1, that would be z raised power n plus 1. Similarly, अगर मैं ये example एक और कर सकता हूँ, let's take z raised power 4 plus 2 iota into z square plus 1. So let's check what would be p of 1 by z. P of 1 by z होगा p of 1 by z होगा 1 by z raised power 4 plus twice iota into 1 by z square plus 1. And if I multiply by z raised power 4, this would be 1 plus twice iota into z square plus z raised power 4, which is the same thing as p of z. So this is also a self-reciprocal polynomial. Regarding self-reciprocal polynomials, we have a theorem. And the theorem ये है, if pz is a self-reciprocal polynomial, if p of z is a self-reciprocal polynomial, then as of course degree n of degree n, then maximum of mod z equal to 1, modulus of p dash z is greater than equal to n by 2 into maximum over mod z equal to 1 p of z. The result is sharp and the equality holds for जो हमने अभी एग्जाम्पल and the equality holds for P of Z equal to Z raised power n plus 1. जो हमने अभी देखा वो सेल्फ रेसिप्रोकल पॉलिनोमियल है और प्रूफ भी इसका बड़ा इजी है. So since pz is self reciprocal polynomial, where what p of z is equal to z raised power n into p of 1 by z. On differentiating, we get क्या मिलेगा हमें? Of course, left hand side by p dash z is equal to n times z raised power n minus 1 p of 1 by z, and then you will differentiate, it will be just minus z raised power n minus 2 into p dash of. अब इसमें तुम्हें थोड़ा सा मतलब इसको देखना होगा, राइट? अगर p of z है मतलब जस्ट बिकॉज इसमें आएगा ना रेसिप्रोकल पावर्स, तो उनमें होना तो ये चाहिए ना, उनमें जो पावर्स हैं वो डिफरेंशिएशन से मतलब बढ़ेंगे इन द डिनोमिनेटर, तो फिर हमें ये z raised power -2 का फैक्टर बाहर आएगा मतलब. बट यू कैन इजीली चेक, तुम लो p of z is equal to a raised power n z raised power n plus a1 z plus a naught. So p of 1 by z किसके बराबर आएगा? p equal to of course a n 1 by z raised power n plus so on and so forth plus a1 by z plus a naught. और अगर इसको डिफरेंशिएट करेंगे विद रिस्पेक्ट टू z, तो यहाँ पे उल्टा होगा, ये बोले माइनस एन टाइम्स ए एन z raised to power n plus 1, राइट? बिकॉज z raised power माइनस है तो माइनस एन माइनस 1 आएगा. तो इसी तरह से तुम करते करते जाओगे तो यहाँ मिलेगा माइनस a1 बाई z स्क्वायर, राइट? सो ऑफ कोर्स फिर अगर इसको z raised power n minus 2 से मतलब you just check it. So it would be, अगर मैं z raised power n minus 2 को बाहर निकालूं and you will see that you will get the same thing, मतलब verify it yourself. ज्यादा मुश्किल नहीं है डिफरेंशिएशन करना, और चूंकि यहाँ टाइम का थोड़ा ख्याल रखना है तो anyways, so this is what we get on differentiation. But if I multiply both sides by z, so you would have z into p dash z is equal to n into z raised power n p of 1 by z minus z raised power n minus 1 into p dash of 1 by z. So which is the same thing as n of p of z because it is self-reciprocal polynomial. So we get minus z n minus 1 p dash of 1 by z. So which implies that z raised power n minus 1 into p dash of 1 by z is equal to, इसको यहाँ ले जाते हैं, so it would be, यहाँ ले गए, इसको वहाँ वापस लाएंगे, it would be n of p of z minus z into p dash z. Okay, as usual जैसा कि हम मॉड लेंगे दोनों साइड्स पे, it implies that modulus of n of p of z minus z times p dash z is equal to z raised power n minus 2 n minus 1 p dash of 1 by z. So which implies that maximum of mod z equal to 1 z p of z minus z times p dash of z, of course is equal, is the same as maximum over mod z equal to 1 modulus of z raised power n minus 1 p dash of 1 by z, which is the same thing as maximum over mod z equal to 1 p dash of z. Now again you have to check this, मतलब उतना मुश्किल वैसे होना नहीं चाहिए. So चलो अगर ना तुम देखना चाहो p of z is equal to, what do I have? So it is, चलो मैं एक सिंपल एग्जांपल लेता हूँ, सी क्वाड्रेटिक लेते हैं क्योंकि वो जरा जल्दी हो जाएगा. So what would be p of 1 by z? would be a2 divided by z square plus a1 divided by z plus a naught. And if I multiply by, if I differentiate it, so p dash of 1 by z जो होगा, it would be, let's see, it would be minus twice a2 divided by z cube, right? Minus a1 divided by z square. Differentiate किया हमने. Okay, so you have, okay, now what would be z? अब ना देखो z रेज पर n minus 1, क्योंकि इसकी डिग्री क्या है p की, p हमने लिया था सेकंड डिग्री. सो अगर मैं इसको z से मल्टीप्लाई करूं, सो z से मल्टीप्लाई करने के बाद I would get minus twice a2 by z square minus a1 by z, which is equal to minus p of p dash of 1 by z. You can easily check. So मैं क्या कर रहा हूँ, हाँ तो ये तो गड़बड़ हो गई कुछ. मैंने क्या लिखा, p dash of 1 by z ये है. Let me try it. So मैंने इसको डिफरेंशिएट किया, this is what you get. तो मैंने क्या लिखा, z raised power n minus 1 into p dash z. It is actually, जब मैंने इसको मल्टीप्लाई किससे मुझे करना था, we observed the degree n, so I just multiplied by z. तो हमें ये मिलेगा, हाँ, which is the same, इसको मैं लिख सकता हूँ 1 by minus 1 by z square. मैंने इसको मल्टीप्लाई किया तो you will get this. क्या करेगा मुझे, अगर मैं माइनस z को कॉमन निकालूं, कुछ चीज को मुझे कॉमन निकालना होगा. सो राइट, क्योंकि वहां पे आएगा ट्वाइस. इसको डिफरेंशिएट अगर सीधे करें तो क्या मिलेगा मुझे, a twice a2z plus a1. राइट, तो इसको अगर हम ऐसे लिखें, एडमिट, इसको अगर हम ऐसे लिखें minus 1 by z into twice a2 divided by z plus a1. So this is actually equal to minus 1 by z into p of 1 by z, p dash of 1 by z. So in modulus, कुछ तो मैं गलत कर रहा हूँ यहाँ पे. What would be p dash of z? Okay, फिर से मैं इसको देखता हूँ. I've got p of 1 by z इसके बराबर है, फिर इसको डिफरेंशिएट करेंगे तो ये होगा. कुछ गड़बड़ हो गई यहाँ पे. Okay, you got minus 1 raised to 3, that's okay. Okay. So you have got, in modulus, this should be the same as p dash z. Okay. So p of 1 by z इसके बराबर है, p dash of 1 by z इसके बराबर है, और z into p dash of 1 by z will be equal to, हाँ, अगर मैं mod z को equal to 1 लेता हूँ तो ये सही होगा, राइट, क्योंकि मैं ले रहा हूँ ना mod z equal to 1. So mod z अगर 1 के बराबर है, so I can just take it out. I can just take it. So it is minus twice a2 divided by z square minus a1 by z. So if I take 1 minus 1 by z2 out, okay, multiply. ये confusion है. मुझे किसी ऐसे नंबर से मल्टीप्लाई और डिवाइड करना है जिसको mod z equal to 1 पे कोई फर्क ना पड़े, और वो साफ लग रहा है क्या होना चाहिए. So लेकिन यहाँ पे I want, चलो मैं पहले ही लिख देता हूँ. I want twice a2 z square plus a1. तो बाहर क्या आएगा, एक तो माइनस आएगा, twice a2 तो था ही, z square यहाँ आ गया, तो I should have 1 by z square. अब ठीक है, हाँ बिल्कुल सही है. हाँ यहाँ पे a1 z आएगा, ठीक है. z square, हाँ ये है एक्चुअली minus 1 by z square into twice a2 z square plus a1 z, a1 सॉरी, a1 ही आएगा ना, क्योंकि मैंने z square को बाहर निकाला. क्या हो रहा है, it would be twice a1 2 -1 z z स्क्वायर को भरने का, तो यहाँ तो कांस्टेंट रहना चाहिए, तो मुझे एक्चुअली z रेज पावर 3 को बाहर निकालना चाहिए। अभी ठीक, अगर मैं 3 को बाहर निकालूं तो यहाँ आएगा z। अरे कुछ मैंने गलत किया कहीं। ओके